Okay, Java on the web. Topic number one, applets. Back in the early days of web development, the ancient days, some 7 years ago or so, Java or applets were highly hyped by some and were, thought to be by some the future of the web and the future of Java. That was the application, the killer app for Java, and that was going to go revolutionize the web. Everybody would be doing applets with their programs. This turned out not to be the case in either situation. Applets turned out not to be the future of the web, but fortunately they weren't the future of Java either, but Java nonetheless seemed to have survived the collapse of applets. The goal of applets, as you recall, was to solve a number of problems that arose on the web. The early web UIs were pretty lame. They gave you very basic buttons and text input frames, and when you basically had to do a round trip to the server to get any interaction at all. In fact, our current class server pretty much still works on that model. So Java, the idea of Java is you'd be able to build Java programs using the full Java UI capabilities, embed them in a web page, download them, and then have a full, essentially client-side UI running in your web page. And so you could use all the nice widgets that Swing has, or the predecessor to Swing back then. Excuse me. And you could, your application would be interactive, and only when you absolutely needed to go back to the server would you do that. And there was a subsidiary goal that because you're writing in Java rather than C or C++, you had this write once, run anywhere, and it was supposed to be platform independent. And because it didn't run on native code, it ran in this Java bytecode format. It was platform independent. So and it was mobile, so that you could download it, and it wouldn't have to link to local libraries or worry about any of that. And so it was kind of this whole cool vision. And point of fact, as I said, it did not come to pass for a number of reasons. Competing technologies came along, in particular client-side scripting, JavaScript, and I think VBScript runs on the client. JavaScript, as I mentioned in the first lecture, has almost nothing to do with Java, except that Netscape, it was originally called LiveScript, and due to a last-minute marketing deal between Sun and Netscape, they changed the name to Java to kind of combine buzz. The other thing that really kind of came along was plugins. Plugins are another sort of mobile technology that you can download and install, but they're much less automatic than the applet idea. They have to be compiled for a particular architecture. They don't have any of the safety features that applets do. The nice thing about applets is they were going to run in this kind of sandbox where they couldn't get access to your file system or go make network connections to arbitrary places. They were limited very much in what they could do, so they were considered safe. Whereas plugins are just native programs that you download and install. Hopefully you download them from someone you trust. And because they've downloaded, they have the full capability of your native Windows system and the full power of that. But on the other hand, they're a lot more dangerous because they are just programs running on your machine. But it turns out people didn't care that much, and for big things that really needed a lot of power, like your Flash player, your Adobe Acrobat Reader, your PDF reader, this sort of thing, people seem to be happy to download plugins, and the rest people would buy some combination of embedding tables and tables and tables and using client-side scripting, basically ended up making very good, nice-looking UIs without applets. So the state of applets today is pretty sad. I wanted to give you an applet demonstration, but it's almost impossible. The problems being massive incompatibility. You would think that the goal would be write once, run anywhere, but the browsers that we have here, Netscape 4 and IE, will run the old applets from backward compatible from the late 80s, which is built on Java 1.0 and maybe some Java 1.1. I don't know whether they ported to the new event model or not. So this is what you can get if you have Netscape 4 or IE, and I think we have all Netscape 4. If you have Netscape or earlier versions if you have Netscape 6 or IE5, Microsoft and Sun went in different directions in the Java virtual machines they were supporting. So that led to some incompatibility. Plus, Java has evolved into 1.2 and 1.3, and then there's the swing set that was added that wasn't in these earlier versions. So if you have a Java 1.3 swing application, like for example your game, and want to turn that into an applet, it's difficult. These do not have, I think, this one does not have a native virtual machine, though you can point it at your virtual machine. And there's a plugin you can get from Sun called the Java plugin, which you can install as a plugin in your browser, which will run, I think, up to 1.3 swing applications. But that was just too much of a hassle for me to go and download and install this plugin and get it working on this machine to try and demonstrate applets. And I suspect it's too much trouble for almost anyone. So if you have an applet written in the 1.3 swing version, the chances are that anybody will actually go through the trouble of downloading it and using it are probably small, which is too bad because those games we did would probably make pretty nice applets since they don't talk to the file system of the network. They're pure GUI instantiations.
Why do you think no one would bother to download it?
I think that the people have found that the overhead for downloading a plugin is pretty high. You have to provide some pretty good functionality that people really, really want in order for them to go through the trouble of downloading and installing a plugin. Even if you have, the link to the plugin install on your page. I mean,
The 1.2 plugins are only available for a very limited subset of platforms too, unlike the 1.1 Java implementations in Netscape, which is available for a lot of different platforms.
Oh, is that so? So, I mean, is it not available for Linux, for example, or?
I'm not sure about Linux. I know it's not available for Linux on the Mac or the Mac,
Ah,
Amiga, or anything.
I see. Yeah, anything that's not Unix or Windows really gets shortchanged in some of these. On the other hand, making an applet, should you choose to do it, is pretty easy. And applets are just classes, like everything else. And to build a applet instead of an application, say you have a GUI application that has a main and a main class and inherits, has its GUI starting from JFrame, it's pretty easy to reorganize it as an applet. The top-level class for applets is naturally called JApplet. So you have to make something that inherits from JApplet. And JApplet has 4 basic routines that you have to overwrite in it. What are they? Start. Stop. Init is a one-time only call. As soon as your applet is loaded into the browser, the init routine gets called. So this is where any one-time initializations for your program get called. This is where you want to put your one-time initializations. Start gets called every time every time a user enters a page with your applet in it. Okay, and so that's where you want to put the start of the actual activity in GUI, and that's where you would initialize your game if you were doing the game. Stop is called every time your program, every time the user leaves a page with your applet in it. So if they decide they don't like your game and go on to something else, stop will be called. And destroy is guaranteed to be called on browser shutdown, so you can clean up anything that you messed.
Different users started your applet. Wouldn't it be called once per user?
Well, remember this runs in the browser. Okay, this is on a web. Let's draw a web picture because we'll need it later. Browser, server. And the applet lives here, but when it's invoked by a page, the code is downloaded and it runs in a Java here. So if two people open different browsers, they'll each get different copies of Java running in different virtual machines, and there'll be no conflict. If you have two people sitting in front of the same machine, it might be, they'll clearly be sharing. If you open two browsers on the same machine, to be honest, I don't know whether they share virtual machines, so it might get loaded only once. Netscape might just give you separate displays, but really maintain the same GUI interface. So how do you, to make an applet, you just extend this class, implement these routines, compile it into a .class file, put it in your server path, and now what you have to do is have a URL associated with it so somebody can access it. And that's pretty easy. Well, it used to be pretty easy. Now it's a disaster. It used to be that, in your HTML, I'm assuming you're all familiar to a certain extent with HTML, so if you're not, it's just a lot of angle brackets. And you have blah, 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 the rest of your page, and say in the middle of it you want to put an applet. There used to be a nice tag called applet, where you give it, let me go refer to my arguments here. Arguments, this is how you specify attributes in XML tags. Code equals, and then the path of your code. My applet, say, .class. No commas, and then you need to tell how much real estate you are going to use. So if you want a 300 by 300 game, you put width and height 300. Put in that tag, and this will embed the applet. It'll tell the page I need this many pixels by this many pixels. It'll instantiate the applet and run it in some 300 by 300 window, more square than that, in your page. So one thing I neglected to mention is when you're inheriting from JApplet, you want to get rid of all the stuff involving JFrame. In particular, you want to put all of your components into the applet rather than in the component frame of JFrame. You don't want to set the size of JFrame because you're doing it here. You don't want to set the default close action because that's taken care of here. You don't want to call JFrame show. All the stuff you used to do on JFrame, you just bag, and all that will be taken care of by the applet in this tag. The rest of the stuff, your code, you just distribute between your init routine, start routine, stop routine, and destroy routine. And then you can call this. Unfortunately, in HTML 4.0, the applet tag has been deprecated. And we have instead the use of the Java plugin. And to use that, you have another set of tags, which unfortunately are different between Internet Explorer and Netscape. In one, you use this embed tag, which has a whole pile of, of these attributes, and you finally somewhere specify these and these deep inside. To use, i.e., you use the object tag, which has about 35 attributes, and it's very general for downloading any kinds of binary components and objects and controls and doing all sorts of stuff. The bad part of it is that to do anything at all is quite complex. It doesn't have that nice gentle slope property that you like, that simple things are simple and complicated things are complicated. That's a nice feature, but a lot of programming technologies these days are getting away from that, and they're going for complete generality for the expert programmer, but nonetheless, simple things are really complicated to do. And Java is guilty of that as anyone, as you can see from their I/O stream system, where in order to print something to a file, you need 3 or 4 classes. All right, enough about applets. I'm going to try and get on to servlets in hopes that we can actually show something.
So if this is a plug-in, it's not safe anymore? Yeah.
The Java virtual machine is a plug-in, but you trust Sun, and then when the applets run in the virtual machine, they're still in the sandbox, so they cannot access the file system or foreign network connections or anything like that. So. All right, before we go on to the next Java technology, very brief introduction to web programming, which will probably be redundant for most of you. In the web programming model, we have our clients, which is the browser, and of course we have a whole world full of these guys, all simultaneously hitting us. And we have our server, which has our website stuff on it. Now, the most straightforward thing to do is to serve way to make a website is to serve static pages. You just write a bunch of HTML documents, put them on a file system in your local server, and the browser requests them. It goes and fetches, let's draw a little file system picture here, fetches this document off of the file system, which is in text HTML, and dumps it back to the browser, which then displays it. And the URL contains the path in the, some fraction of the URL contains the path in this file system where to find this document. So that's the easiest way to program a website. The trouble with that is it's static. You have to build all of the pages that you want to build ahead of time. So gradually, people wanted to build dynamic websites. They wanted to access databases. They wanted to, if you want to have a website that will tell you what the current weather is, or the current time, or a current stock quote, or something like that, you need dynamic information. The HTML you send back each time cannot be static. So the first attempt at this, very early on, was something called CGI, for Common Gateway Interface. And the idea of this was that a certain fraction of the server's namespace, the URL namespace on the server, was turned over to things that weren't going to be static web pages, but were going to be programs. Okay, usually the directory CGI bin, anything under here would be considered a program. And so what the server did was fork off a process, invoke whatever program is here, myprog.pl. So here it would run myprog. Okay, so it would fork off this as a separate process, and the standard output of this process it would catch and then route back to the server. So the job of this guy, this program, which could be written in C, could have been written in Perl, could have been written in anything, but its job is to write out text HTML on its standard out. Standard out is roughly the equivalent of system.out in Java. It's what you would send to the terminal normally. In this system, it's redirected through the server and sent back to the browser. The browser just sees this HTML stream coming to it. It can't tell the difference between whether it was coming from a static file or built dynamically from a program, so it just displays it. So this is cool because this program can then access, your stock database and give it back. The problem with this scheme is that it turned out to be fairly expensive because every time you wanted to run one of these things, you had to fork off a new process. And so if you're getting thousands of hits per minute, you're forking off thousands of new processes a minute, and that gets very expensive. And so people came up with schemes that you pre-allocated the processes and just told them which program to execute ahead of time. But gradually another scheme evolved to run multi-threaded servers. So in these things, there are a more limited number of languages that they support, but inside the server, they will support a little multi-threaded sandbox where you can run in the server process, but each having its own thread, different scripts or programs. And usually each web server will support only a subset of languages that you can bind in here. The nice thing about this is because they're all running in process, you don't have to fork all these new processes, so it's much cheaper, much more lightweight. Another advantage is they can all, if there's a database out there, they can all share a common pool of connections, because connections to a database are expensive to create and destroy. And so they can share a common pool of these things. So what happens is a request comes in, it gets bound to some program that runs. A new thread is started to run that. The program is instantiated. It runs. Again, it sends its output back through standard out, back to the client. And this is an important thing about HTTP, is that it's a state-free protocol. Okay? The basic operation is the client connects. The server runs the program or finds the page, sends the data back, and then the whole connection disappears, and that program disappears. And then it happens again. The next request, the client comes in here, a new program is started, does that, and then it vanishes again. Every connection, the program starts up, the thread rather, starts up, does its thing, and dies. So this is fine for doing things like stock quotes, but say you want to do a shopping application, all right? So say you want to put things into the shopping cart. You have a problem here because whatever is monitoring or standing in for the client, all the programs that are generating these pages disappear at the end of every transaction. So you say, I want this in my shopping cart. Then on another page, you say, I want this in my shopping cart. Okay? The whole process that's supporting you on the far side is being killed at every transaction. So if you just were storing what's in the shopping cart in memory, say in instance variables or something, in a regular program, that program would die, and you'd lose the information of what's in the shopping cart. So to deal with this problem, lots of schemes came up, and there's a lot of different ones, but they all essentially implement the same thing of some kind of what's called session management. So they allow you to have, on the server side, persistent data associated with what's called a session. And a session is kind of a user talking to some particular server within, say, a half hour or something. So if you talk to the same server again and again within a short amount of time, it's considered the same session. But still, the protocol is still state-free, so you have a problem, two problems really. One is how to store all the data associated with a current user's transaction, their shopping cart, where they are in the process, all the things that would normally stored on your call stack in a program or your data on a call stack. You need a place to store all that. And there they give you a session object that they're guaranteed, these systems behind you are guaranteed to be persistent and hang around for you. And then you need a way of finding this again. When the same user connects to you again, you need a way to reconnect him with the right session object, because you have thousands of these floating around for all of the different sessions currently active. And this is usually done in two ways. One is called URL rewriting, in that you encode in the URLs that the user is sending back and forth, and hidden in the pages that you send down, some ID that lets you get at this. Okay, this is very nice general scheme. The other scheme uses cookies, in that cookies are a little file that you can store on the user's machine that will uniquely identify that user and that machine. So, and there's ways to attach that cookie to the URL request, so that when the user makes a request, his cookie gets sent along. You can identify the user. You can also then connect him with his session object again, and then you can let him, you've retrieved a shopping cart where he is in the process, whether he wanted to sell 1,000 shares or buy 1,000 shares, all of this information. Of course, the servers, if they are not well-intentioned, having this information can also spy on the users, track what they're doing, figure out what they've bought, and keep all sorts of statistics on them. So, did we get anywhere with this? Yes. So, Java's entry into this technology, the running web programs, Java has two entries actually into running in-process web programs. They differ in the way you author your web pages, and they are called one of them is called servlets, and one of them is called JSP for Java server pages. And these are underlyingly, they are the same technology, but as I say, they're different offering techniques. With servlets, you basically write Java code that spits out HTML using printlns. All right? In JSP, you basically write normal HTML pages that have special tags that call into Java that gets interpreted on the server side. So you have a regular HTML page with special tags. It gets read in, and before it gets sent out, all that Java special tags are interpreted here and sent back. In truth, what happens is JSP pages get compiled into servlets, which dump the HTML in printlns, but that's transparent to the user. So servlets, let's talk about servlets. Servlets are, again, just objects like applets, fairly easy to write. They inherit from the servlet class, and Java gives you actually another subclass of servlet called HTTP servlet that has a bunch of utilities on it that are very nice for just writing HTTP code. The servlet class is very general. And to write a servlet, you just extend servlet. So we would write serve test. Extends HTTP servlet. And we have to override, again, some routines on HTTP servlet to make things work. The two important ones are init and service. And maybe I will try, rather than reproducing this code, to show you actual things working. Ha ha ha. All right, so here is a sample servlet. I will blow it up a little bit here. So my public class serve test, I'm extending HTTP servlet. I don't really have any one-time init functions. Okay, init gets run the very first time anybody anywhere calls the servlet. And this is a pretty lame servlet, so it doesn't really have any init functions. The service routine is the thing that gets called every time somebody connects to the servlet. What happens is a new thread is started. It runs, the system calls the service routine on that thread, and your code executes. When the service routine returns, the thread dies and you're all done. So service gets called with two arguments that are chock full of interesting stuff. The request argument is of type servlet request, and what that does is has all the information about the HTTP request the user made from you. It has all of the header information like user agent, what kind of browser the user is coming from, what type of command they're doing. It has any query args they sent from filling out a form. All of that information is packaged up in the request object. The response object is the pointer back to the user. It has information about what you want to send back, and in particular, it has a print writer on it. So here we're just going to get a print writer. We also are allowed to set header information to send back, and it's always good to set the MIME type on a web page when you send it back. So here I'm telling the browser that it's to expect text and it's HTML that's coming back. And I set that on the response since that's what gets sent back. And I also get, okay, this is slightly more complicated than one could do. You can request something called a session object. These are the three important objects for doing server-side development. And they're pretty much map across all equivalent instantiations of this, whether you're using ASP or PHP or JSP or servlets or whatever. You need your request object, your response object, and your session object. And the session object is just this thing down here where we have to keep all of our user data for this session. Now we have a servlet here, so you might think, well, I can put instance variables here and call other classes and everything would be good. But the odd thing about the way servlets work is you get exactly one copy of every servlet in the virtual machine, and that is multi-threaded like mad to serve all the requesting clients. Okay, so any instance variables here that you put up there are going to be shared by all of the threads, all of the people calling into your server at any given time. So if you have any, they ought to be read-only because they're going to be updated like mad. And you have massive synchronization problems on them if you do use them for anything. You could try and get around that by synchronizing the service routine or routines that access those variables. But remember, that's going to serialize all of the people who are trying to connect to your server and slow down your response time. So all of the state of your program, anything, if you're writing what you used to think of as a sequential program to deal with a user's call flow, for example, first they want to log in, then they want to browse, then they want to add stuff to the shopping cart, then they want to check out, then you want to get their, all of that state, where you are in that process, what information you've collected so far. This all has to go into the session object or into a back-end database, if you like. The session object is guaranteed to be persistent between different calls by the same user within a certain period of time. Usually you can either explicitly kill it on the server side or it'll time out if they haven't connected in half an hour or so. And the Java system will automatically decide whether to use cookies or URL rewriting. And so what I'm doing here also is getting a, so what I'm going to do is try and take advantage of this. So I'm writing some code to get an attribute out. One of the things that sessions support, the way you get data in, is essentially works like a hash table. You can put data values in based on keywords and get data values out based on keywords. And these data values can be full objects and tree, object classes and stuff, and everything will work, or object instances. So here I'm just looking for something called count. And if I haven't put one in, I'm going to make one to 0. And then whatever I've got, I'm going to increment it and then put it back in. Now, the only thing you can put in sessions is object types like integer. You can't put basic types like int. So I have to use the object wrapper for integer to do this. So all this does is it reads a count out of there, increments it, sets it back in, and then saves the value in count. And then the rest of my program is just doing a bunch of printlns, which generate HTML. So the usual boilerplate HTML head, title, test, blah, 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 close that. Then my body, I'm going to put out a banner that says ADU servlets h1, and then I'm just going to put a line that says count equals and put this count variable. So if all is well, this count variable will increment every time I access this, but every user who connects will get their own version of a count variable so that it will count each user separately. All right, so now we have one of these things, and we just compile it like normal, except I'm not going to do it on this machine since it doesn't seem to have these classes. And then we need to run it. So we need a server that will support, as I said, each server supports a different set of languages in their in-process web stuff. AOL server, which we use here, supports Tickle, and I think they have a C API. Apache has a lot of plugin modules for various languages. They have one for Perl, which is one of the popular ones. Java, being so complex, uses a somewhat different mechanism, or you can, where's my eraser? You can connect it to, say, Apache in two ways. You could run a separate server, which is JServe, which runs all your Java servlets. And then this connects to the main web server, which, when you're trying to fork off a servlet, puts it in calls, forks the thread off in this process and does the usual thing back. Alternatively, you can have a special server which has a Java container in it, which is what I have here. This one called Apache Tomcat, which is a native servlet container. And so we'll run in this format. If I use Tomcat, it'll run the Java programs in process. The disadvantage is that although it's optimized for running Java servlets, it's less efficient than, say, regular Apache or AOL server at running static web pages or CGI or whatever. So if you had a real site, you'd probably want to run this just for your Java pages, your main server for your non-Java pages, and connect them through a back door, which is all accounted for. But all right, let's see if we can get this going again. Let's see, GCSH. Java / Jakarta / bin. All right, and path / temp Java / JDK bin. Path dot colon path. All right, here's the moment of truth, or one of the moments of truth. Come on. No, it's thinking. Not bad. All right. So, oops. call up Netscape. Hope we are all holding our breaths. All right, so far so good. Now, Tomcat starts up on our machine on port 8080, so we can first check that it's up. All right, thanks. TP:// localhost :8080, and fingers crossed, yes, Tomcat's up. And as it took me a while to figure out the right place to copy your class file, once you've compiled your class file, you have to copy it in a directory that Tomcat knows about it and knows to think of it as a server class. And I have done that. And this is one of those things that is not gentle slope. It took me a while to figure this out. So servlet serve test. And now it's thinking while it compiles for the first time my servlet and loads it up and does all that stuff. And if we are really lucky, yes, we have hello ADU servlet. Ooh. And now, look at that. As we reload our count increments, and if we had another machine that would connect to it, and its count would start out at 0, and we could both increment our counts separately. No, I've tried that. They share cookies. It's using cookies to identify, and the cookies are stored on the file system, so any Netscape on this file system will pretty much behave the same.
Yeah, use two links.
Oh, no. This is, we're walking on eggshells here. And there's one more thing I want to show. So just hold your breaths. The final thing I want to talk about and show is JSP. Yes, please.
Servlets are essentially just dynamic web pages where you've got some database backend or something like that, and you're generating pages to spit back at the...
Servlets are essentially Java programs that are generating dynamic HTML on their output. Now, they could certainly be talking to a database as part of their operation, and typically they are. The typical web application is what they call 3-tier, where you have your browser, your client, your web server running your CGIs or your servlets, and then a database like Oracle, which is holding persistent user information, managing transactions, and carrying all the important stuff.
Now, does JServe do any caching of these dynamic web pages, or are they considered so special and unique that it's unnecessary?
You mean the HTML that a Java computes as it produces? It typically would not cache that. The browser might cache that. But on the other hand, since it's dynamic and you don't know, there's no way to tell whether it's going to be the same every time, you really can't cache them. So the servlets need to run every time because you don't know.
That it might be possible that typically you get the same sorts of requests, maybe not. It might also be possible to look at all the differences between these typical things in memory and...
The trouble is it's very hard to tell because the response you send back is a function of the URL, including query args, the state of the session, and the state of the database. Okay? And only if all three of those things are identically the same are you guaranteed to send back the same HTML.
Oh, yeah.
And so the amount of time it takes to do that comparison is way longer than the amount of time it just takes to do the computation.
Threads run every time you use a servlet?
Every time you do a request in, the thread is assigned, yes. And then it gets reassigned to somebody else. But threads are cheap, which is why they do it in process.
It still seems expensive to generate a page.
As opposed to just using a file?
I don't know.
Oh.
It just seems like it would take up a lot, but...
Well, you're doing a lot of stuff. So it is, the question isn't this an expensive mechanism? And it is. And Philip, when he gives his course, will complain that it is expensive because you're running Java here and whatever, and say that the thing to do is run a much cheaper, more lightweight thing here, like Tickle, and then push a lot more work onto the database, which is a legitimate approach. So you really just have to see. Again, using Java on the server is nice for the programmer and may or may not be fast enough to satisfy your user community. It really depends on what kind of traffic you expect and whether it's better to buy more server machines than it is to hire more programmers in a more complex programming environment or difficult programming environment that might be faster. So there's a lot of trade-offs. Which brings us kind of to our next topic. After doing a lot of client server-side programming, either in Perl or Tickle or Servlets, people noticed a number of problems with this. One is that you spend a lot of time in your code just doing printlns of HTML. Here we had a very simple page, and yet a third of our program is printlns. If we were trying to generate a page that was hundreds of lines of HTML, okay, we'd have these things all over the place. Granted, we'd have utility classes to generate tables or whatever, but still, a lot of our code would be generated to these things. Second problem, if you think about a group that's designing and maintaining a website, okay, lots of people, their roles are going to be split up. There's going to be some people who are really in charge of the presentation. And these are HTML programmers who know how to make a page look good. Then there's the programmers who know about how to connect to a database and how to get the right information out of the database. And then there might be a separate set, or they might be the same as the database set, who are in charge of what's called the business logic, what transactions on the database are allowed, what the basic process you're trying to accomplish is. Okay? So one of the things you want to do to get this group to work together smoothly is separate the presentation from the back-end business logic and programming. This is a recurrent theme in what's called enterprise programming, where you have lots of people working on something. You want to separate the people working on the presentation from the people working on the programming. And here it's all mixed up because the programming is done, the presentation is all embedded in the program. So your HTML designer has to be working on the same file that your logic programmer and your Java programmers are working on. So gradually, a new way of thinking evolved. And there's a bunch of instances of this. Java instance is called JSP. There's one called ASP, which is Active Server Pages from Microsoft. There's one called PHP, which no longer stands for anything. And there is Cold Fusion from Alaire. And there's probably more I've neglected. And the model here is you simply write your normal HTML, but you put in special tags that have server-side scripting. Now, client-side scripting had been supported for a long time. You could embed things that would call JavaScript or VBScript on the client to fancy up your UI. These are server-side scripts, which mean these files live as normal web pages, theoretically. But before they are sent down to the browser, all of the special tags are evaluated by your special ASP, JSP, PHP server technology. And JSP has a number of different types of tags. The simplest one, just like this, where you can write arbitrary Java code in there. There's another one that I'll show in a sec that starts like this. Okay, these, the syntax of these gets a little obscure. This one, you put a Java expression here. The expression is evaluated, converted to a string, and the string is embedded in the HTML stream wherever this tag happens to be. Okay, so you can see you can build up exactly the same page we did before, but in reverse. Instead of putting the HTML inside the code, we invert it and we put the code inside the HTML. Now, this doesn't quite solve our problem of separating the presentation. This makes the presentation people happy because they're all writing their HTML, which they like to do, or using tools to write the HTML, which they probably like to do better. But now, what do the back-end programmers do? Well, this kind of segues into tomorrow's topic, which is components, scriptable components. What the tendency people are going towards is, instead of embedding the actual code that you'd like to do massively in these segments, if you're doing a lot of complicated coding, you don't want to necessarily embed that in these poor presentation guys' server pages. So what you do is you package them up in what's called components, binary components. And the Java technology for that we'll talk about tomorrow is Java Beans. And if you're using Windows, you would use ActiveX. And so the idea of these is they package up a lot of technology. They're essentially classes. You can think of them as classes that are wrapped in an interface. And they encapsulate all the functionality and expose only those methods that the system actually needs to proceed at the high level, but all the guts are hidden inside of here. So that all you really need to do in these script tags is invoke one of these things and then call some properties or some methods on it. And so most of the tags in JavaScript and JSP are geared towards implementing that technology. That's a little too complicated for our poor server thing here, but let's see if I have a JSP page. All right, here's kind of a minimalist JSP page. It's basically HTML. I'm typing hello JSP, and then I'll type the time is now. This is normal HTML here. And here's my magic special tag, which is accessing Java, the Java virtual machine. It's one of these expression tags, open angle bracket %sign equals. And I'm creating a new date object from Java util date. I'm calling the toString method, so this should be a string representation of the current date. And then, because it's here, it's just going to embed it in the HTML right where it would normally go, so following the time is now. And let's see, where did I put this? This you, again, put in the web server hierarchy. And I forget where I put it, so we may have to search around. Not found. Yes, that's where I put it. OK, so basically what happens is that this whole thing just evaluates normally, except the server processes this and converts it to our current time, which is not quite correct, but. And as I reload it each time, this gets dynamically updated, so my time increases second by second. OK, both of these topics, servlets and JSP, are big topics, as is web programming in general. And this three-tiered architecture, we've just scratched the surface, or even the surface of the surface. There are whole books on JSP. There's whole books on servlets. There's whole huge books on all of these things. And if you're interested more, by all means, go and look at the books. The O'Reilly servlet book is pretty good. The O'Reilly JSP book is pretty good, assuming you've read the O'Reilly servlet book. I do not, as yet, know a good ASP book, intro ASP book. So if anybody has one they're happy with, please let me know. And that's the situation with Java on the web. It's right now there's a lot of action going on, in particular because the Apache people are doing a lot of interesting stuff with XML and Java and XSLT. And it's pretty cool technology. They have another server called Cocoon, which really combines all of these technologies together. Whether it'll be fast enough for real operation, who knows? But it's pretty cool stuff. And so that's kind of driving enthusiasm for Java on the server side. And I think currently JSP is probably gaining ascendancy over servlets. The JSP Java Bean combination is probably gaining ascendancy over pure servlets because of this idea of separating the presentation and the business logic.